Hello there, my YouTube fellow beginning programmers. This morning I woke up and I decided to, just play around a little bit with programming, and let's see if we can create maybe a tic tac toe game real quick with just HTML. Let's see. First of all, I think there's a grid in HTML. Let's see if we can even get the board drawing out. Let's see. So grid layout. Let's take a look. I think we can probably cheat a little bit. Oh, look at here. This is a pretty good grid. So how did they do it? Grid item, grid container. And they did it just like this. Can we even pull this off? Inline grid. This doesn't seem to be doing anything other than just a bunch of items. Doesn't talk about the layout. What if we did that? Let's see. If we took all of this and let's go into what is that? Online. I forget what it's called. Let's see. Online HTML editor. I forget what it's called. Not that one. Not that one. Not JS Fiddle. I forget what it's called. What is that thing called? Can't think of the name. Online JS editor. Okay, maybe JS. Let's see. JS Fiddle comes up. I know about JS Bin, but that's not what I'm looking for. I'm looking for that other one. I can't remember the name of it. It's not REPL. Wow, what is it? Not Code Sandbox. Okay, what if we say CSS editor? Not Scratchpad. What if I look for the word how to create arrow comment arrow tooltip? If I go there, I know it's going to take me to Stack Overflow, then it's going to take me to, see, that's a JS Fiddle. I don't want JS Fiddle. Everything's showing me JS Fiddle. I don't want JS Fiddle. Where's this taking me? Let's see, and then maximize this, see if I can see what it is. Not there. Why can't I find it? Normally I find it really easy like this. Let's see if we find another one. GitHub. I don't want that. Why can't I think of the name? You would think that it would come right up. JS Bin comes right up. I I cannot think of that name. It's not J as Ben, it's not J as Fiddle. Oh. It's not J as Ben. No, not J as Ben. We could do it with J as Ben, but let's see. I can't find the name of that other one, so let's just put the HTML right here. Okay, so give us a grid just that quick. And then if we wanted to handle click events, instead of that, we can give it values, variables. We won't give it anything just yet. Let's see our styling gap, 50 pixels. We don't want that many pixels. Let's do 10. And then what did we said? Container, the gap, the grid item. Can we give this minimum height? Okay, we gave it minimum height. And then what did we give it font size? And let's say we gave it about, let's see, 28 or something. Let's put something in it. X. That's good enough. Okay. So now how are we going to handle the clicks? Well, that's where our JavaScript comes in. So let's open up the JavaScript, and how we can do that is handle the clicks. One way to do that would be to do on click. What if we did this? Just plain and simple. Well, let's test one out. So what if we set this? Let's just call this make move for now. And for now, we're just not gonna do anything complicated other than we're gonna give our panel an integer. So we'll say make move 1. And so in this we have position, and we're gonna say and we are going to have to give these IDs. So let's give it an ID of 1. ID equals 1. Well, we'll say board 1, like that. So we can say document get element by ID, board plus position, and we'll say element, and then to write on it, element How do we write onto a div? Let's see. Oh. Click OK. Inner HTML. So we have to make sure we spell the casing right. So it's inner HTML. Okay. Let's see if this works. Click on it. Oh, and there it is. See, we got something there. Okay, so we got something clicking. So we're gonna do this to all of them. And of course, once we do this, we're going to have to give each one of these a different ID. So for this one is 1, of course. This one is 2. This one is 3, 4, 5, 6, 7, 8, and 9. And of course, they all got their own IDs. This is 2, 3, 4, 5, and so on. And now when we click each one of these, they convert over. But what if we had a variable? So let's say that we had a variable that determines what it currently is. X is on equals true, and every time they switched it, we could say if we could say let player symbol equal X is on X, otherwise it's O. And then at the end of the move, we convert it over to X is on equals not X is on. That'll toggle it to something different. So if we do that, we should be able to see, oh, it didn't do it. X is on, why didn't it? Let player symbol X is on, X is not on, equal true. Oh, because we didn't use our player symbol here. So we have to make sure that we use our player symbol. Okay, so when we use our player symbol, now it's going to switch. Oh, I still did it wrong. I'm supposed to do this. Paste that here. There we go. Now it should do it. So now we have a Tic Tac Toe game. But that's not enough to get anything done. So what if we had logic? So we need to keep track of whose move it is, right? So one of the things about this is that in order to have game logic, typically you got to have some kind of game in the board and everything in memory without even worrying about what's actually drawn out to the screen. So typically for something like that, you would need to have a virtual board. So we can let our board be equal to just an array, right? And what we can do is initially our array needs to be filled with values of just actually values, not characters but values. So our virtual board is going to be all zeros. So we make an array of 9. Let's see, we have 3 and 3 and 3. So our board is that. So one of the first things that we have to check to see is that in order for us to make our move, before we even do this, we have to check to see if the move is valid, right? So one of the first things we had to say is if move is valid, and then we have to just pass a position, right? So if move is valid, then we move forward with our move, and that's when we switch this on, right? Oh, and we would switch this inside of that logic here. Kind of miss a real editor in cases like this because as you can see, I have to do each individual one. Maybe I don't know how to use it well enough, but it doesn't seem to let me do that. So so if move is valid, we move on, but we don't have a function called move is valid, so we got to create move is valid. So we create another function called move is valid, and then we pass it the position, and we check the board. We say if board, right? If board position equals 0, right? So you say if board position equals 0, and actually we got to do the third equals because we don't want to coerce anything. So if board position equals 0, then return true. Otherwise, return false. And so if the position is valid, right? If the position is valid, then what we want to do is we want to go ahead and and update the game, right? So what we want to do is update the game, and so we say board position equals x is on equals true. Okay, then we put, let's say, a 1, right? Otherwise we put a 2. And keep in mind that we have integers, therefore that's how we're doing this. Okay, so now that we have that, then we make our move. But one of the things about games, and it's kind of interesting, is because you got to separate your display logic from your actual game logic, right? So one of the things that you want to do in a lot of cases like this, instead of doing all this, right, and we switch the X, is do the board drawing separately. So for example, we can draw the board here. So we can say draw board. And here's where we could go through the entire board, right? And draw each div. So one of the things that we want to do, we want to kind of keep this like this, but not quite like this. So what we want to do is we want to do a for loop, and I think you do a for of loop, but we don't have to do that. So we know we have 9 positions, so we go I0, I less than 9, I plus plus, and then we can draw the board. So we know that we have to get this document element, and so we take this code. Oh, I should have took the whole thing. So let's just take this document element, this element, and we take this, and we say if the element, we get to board position, and now it's not position anymore, it's actually I. And so we take I and we say let player symbol equal. Now in this case, we don't do X is on or anything like that. We say what we're gonna do, we gotta choose carefully, and we have a mapping of symbols to values. So what we want to do is we want to do a map, and so we'll say let symbol map equal, and what we want to have is a map where we have, for example, the value 1. I don't think I can do with the value 1. Let's see how we can do a map. I was thinking about doing it this way because maps and properties typically, but since I'm using numbers, then those are invalid. So let's just take this logic out. Let's just create a function for this and say function number to symbol, and we'll say val, and then we'll just do a simple if else, if val equals 1. Oh, I could have done it as an array too. Yeah, let's do that as an array. Why not? Let's do that as an array. So we do it as an array. We could say we'll say let symbols map equal, and we'll throw away the first one. The first one we'll just throw it away. We'll just say, well, actually it's not, we can't throw it away because we actually have 0. So 0, we just have an empty space, and for 1 we have an X, and for 2 we have an O, and so we have a symbols map. So in the here, so here for symbol, player symbol, all we have to do is say symbol map, right? And then symbol map, and we say the board, whatever's in the board I, that'll give us our symbol, because here the symbol map is just saying, okay, give us whatever a value. It's getting the value out of the board first, which is going to be 0, 1, or 2, and 0, 1, or 2 is going to be mapped to empty or X or O, and it's going to give us a value out of there. So then we just take that player symbol and draw the inner HTML of that, and so that's the way to draw the board. So we have that so far. So now what we can do here is every time we make a move, we can go ahead and you know, we could actually make it smarter with if it makes a move, we redraw the map. So typically on a game you would redraw the map no matter what. It's just because it's a game loop, right? So in this case we just say draw map, draw board, and let's see if this works. So let's go ahead and do that. And so we make a move. Oh, and it's not working. Let's see. Let's go into our console. Okay, reference error. Symbol map is not defined. So we misspelled something, obviously. Symbols. So this is symbols map, not symbol map. So let's go ahead and do it again. Inner HTML of null. Okay, because we have 0 less than 9. Well, because we started with 1. So what we need to do is actually move through our board from 1 to less than or equal to 9. So let's go ahead and do that. It just so happened we're hitting 0, so now you can see our map and everything's still working. So, but now what we need to do is put some game logic, right? So whenever the move is valid and the board moves, then we have to handle the logic where the game actually plays. So let's see it. Let's take a, and before I do anything like this, what I'm going to do is I'm going to take just even a simple notepad as I go along, because sometimes your browser may act up. Maybe you do something foolish or something, and what happens is you lose all your code, and we don't want that. So let's just kind of save this as we go. Okay, that's a little backup. Let's save it as a double safety measure. So let's go ahead and put this in C dev. What's a good place to put it? Let's create a new folder. HTML Tic Tac Toe. Okay, so we save it there. We just say this is our backup. So we save it. Okay, good. And we'll just kind of keep that to the side in case something goes wrong. Okay. Are we getting reference errors still? Okay, let me see. Okay, no. Okay, so we can see it switching. So we don't. Okay, so let's clear it. And so the next thing we want to do is put some game logic. So what we want to do is after each move, we want to change our strategy, right? So what we want to do is do AI. Let's call it, for lack of better terms. I know one time at a job, one of the individuals we interviewed said he did AI, and then my manager kind of said, AI, come on, that's too advanced, they don't do AI. But what he didn't realize was that even a game like Pac-Man is credited to be the first game with AI, and all that simply means is the computer is doing the intelligence. So artificial intelligence is just a computer reacting to logic and being smart about things. And sometimes with Pac-Man it was actually a little fuzzy because it was based on a lot of different conditions to where the way the ghosts react, and so it behaved a pretty deterministic, but at the same time it behaved in a way that it was different. Like there's certain tricks to Pac-Man, like I think it's like if the ghost is following you, the pink one, and you turn back to face it, it'll run away from you. Just little things like that in AI, and you don't even realize that they're there, but they are. So anyway, so we're going to create a function called do AI, and we're going to break down our do AI into a few little things. First of all, we're going to check for blocks, right? So make block move, and we're going to make these Boolean. If make do block, if do block is executed, then we don't move on to the next one, right? So we could say if not do block. I always like to use this equals false instead. I don't know why. I know in other languages like Java and C#, I like to do not, but in JavaScript, I just feel a lot safer when I put the equals false instead of the not. So if do block equals false, then you can do say if do win. Well, never you want to do the block first. You want to check to see if you win first. If do win. If do win, then it's over, right? then else, then if you don't win, right, then you do block. Then if you don't do block, actually you could just say if do block, and if you don't do block, then else you're just gonna do anything, just go anywhere, because the first thing you want to do is check if you can win. If you can win, then you leave it alone, right? If you can't win, then you try to block. And if you can't block, then you just go anywhere. At this point, we're not going to make it that smart. So let's just check to see do win. So in the case of do win, we want to check for all the different combinations and all that, and we can brute force it. So we could say a few different ways, like you can check this way and that way and all these things. So I guess one winning combination would be to pass it in the three items and see what their values are, and then you can see if you win. So one of the things, in order for you to win, you got to recognize your symbol, right? So one of the things is that we have to do is that we know our symbol, right? So, and this can get confusing because you could end up with the wrong symbol. So we already switched the symbol, right? So here, we probably shouldn't switch the symbol till we get down here after we draw the board, right? And then we need to switch it back again. We need to switch it back again. So now when we do our win, we just got to do something simple like let's just check to see CheckWin like this and pass it three elements. We'll do it a kind of a brute force approach, and we're gonna pass it the board, and we're gonna pass it 0 board 1 and board 2, right? So we could say check win there. And actually, let's not pass it, let's just pass it the indexes. Let's just pass it the indexes. So we pass it the indexes. Checkboard, that's across the top row, 0, 1, and 2. That's these elements, 0, 1, and 2. We can check if we win there, and then we can check okay, and then, and I know this is gonna get real ugly, so we could just say it if CheckWin. Okay, then game's over, right? No more. Game over. We'll have a game over flag. Game over equals true. So we check win there, and of course we can check win there. So we can say if check win and now let's check all the rows. So now we're gonna check 3, 4, and 5, right? Same thing, game over equals true. And then we take that and then let's copy this logic and check the third row. Else if check win. This is gonna be 6, 7, and 8. And then let's check the columns. And we're going to check, this time, we're going to check 0. And then it's going to be 3. Right? Because we're checking 0, 3, and 6. Right? And then, of course, we check the other ones, which is going to be 1, 4, and 7. And then we're going to check if win is on 3. Let's see. 3. No, it's 2, 3, 4, 5, 2, 5, and 8. So it's 2, 5, and 8. Game over equals true. Right? Then, of course, we got our diagonals, so we can say, we can check win if, and then this time we're going to go with 0, 0, then it's going to be 0, 1, 2, 3, 4, 4, 4, and 8, right? And then one more. And the last one is going to be check if we win here. So this is 2, 3, 4, 2, 4, 2, 4, and let's see, 0, 0. Ooh, I think I'm doing this wrong because actually, I know it's indexes and everything, but well, our board is based on indexes, but we probably should be doing it on this 1, 2, and 3, 1, 2, and 3, 4, 5, and 6, and it's easier to keep track of 7, 8, and 9. And I'll show you why. So let's keep everything non-zero base, 0 index base. So then, of course, this one was 1, 4, and 7. Oh, wait a minute. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 4, 7. 2. 5. 8. And this is 3. Whoa, what am I doing? Okay, hold on a second. So this is supposed to be 1, 4, and 7. And this is supposed to be 2, 5, and 8. And finally 3, 6, and 9. And then finally the diagonal, which is 1, 5, and 9. And then it's going to be 3, 5, and 7. And so here are our CheckWin. So we don't have a CheckWin defined, right? So we have to define CheckWin. Actually, in the do win, one of the things is if we do win, we have to return something, right? We can actually make game over be local. Let game over equal false. Okay, and we just return game over. So if do win, so then we can take and kind of do the same thing with that, but we have to do the CheckWin piece. So if we do CheckWin here, let's see, CheckWin, and then we're gonna have A, B, and C index, right? So we can say, now this takes a whole bunch of logic, because this is gonna be, say for example, if board A equals 0, and of course CheckWin. One of the things about CheckWin, we have to we're looking for our symbol. So we need our symbol. See, we need the symbols again, I think. We need our symbols. So anyway, so we can say okay. So our symbol, I think symbol might be a reserved keyword, so I don't want to use it. So temp symbol and board B equals temp symbol and board C equals temp symbol, right? We can say wins equals true. And what we could do is go ahead and make our move at that point. We could say board A equals temp symbol, like that. Right now we have to turn around and do this for every combination, right? So we have to do it to see if A is empty. In this case, we're saying if A is empty and the other two have our winning symbol, then we go ahead and take the move on A. Then we're gonna have to do that on B, right? So we're gonna have to say temp symbol here, and then we can say the same thing for C. And I'm not doing else if statements. We can do them, but it doesn't matter. It does matter, but not for our simple game. It doesn't really matter that much. So now in this case, we say temp symbol here, and board C equals 0. In other words, if the board is empty. So wins true, return wins. And in this case, the move that we have to take is B. In this case, it's C. Right? So we check for wins that way. But of course, this is a function, so we have to make sure we declare the function. So we're checking for wins. Right? Now, if we don't win, then we have to do the same thing for block, right? So now we have to turn around and execute a lot of this logic for block. And we call that do block. So we check to see if, and this is not really game over. We could just say if blocked. Hope it's not a keyword or some sort in JavaScript. Blocked. Okay. So let's say do block. So block. So now it's gonna check. Instead of doing this, instead of CheckWin, it's going to do check block. So we convert all these over to so now we have a whole bunch of check blocks. So then we're gonna have to do the check block same way as we did the CheckWin. We're gonna have to say check block. And if we do the check block, well, we're gonna look for actually this in this case is going to be reversed, right? So this is gonna be 2 and this is gonna be 1. And so we're gonna say if this in this case is we take it and it's not wins anymore, it's block. So because we're just trying to block, if they could win, we're gonna block them. And this is a lot of logic, but at this point I think we have most of it. So we have check wins. Okay, wait a minute. Do win, do block, and then we now have one more function that we say go anywhere, right? So we're gonna have to create this function called go anywhere. And let's just put it here. And in this case, this function is actually very simple because all we're gonna do is we're going to say, similar to what we did here, we get our symbol. Oh, but one of the things about this temp symbol, okay, is that in the CheckWin, it's okay to use the check symbol, but in the check block, we actually have to use our other symbol. So we had to say let our symbol equal x is on 1, 2, or and so in this case for check block, our symbol is different. So we take our symbol, and that's the move we're making because we're checking to see if the opponent's the player's symbol is here, but that's not what we use if we take the move. If we take the move, we use our symbol in that move. Okay, so now in go anywhere, let's see, go anywhere, all we're gonna do is take that symbol so we take the symbol, Latex wins equal false. So I think there's some logic right now because X is on, X is not on, we actually got to be checking the player's move, but we'll leave it like this for now. We'll come back and fix all that. So if our symbol, so we know that our symbol is that, so we're just gonna loop through the board, and we can actually do a for loop here. Equals 0, I less than, actually I equals 1, we're gonna go from 1, I less than equal to 9, I plus plus, if board I equals 0, we make our move and we say board I equals temp symbol, and we break out of the loop, and that's how we make our move. So that's how we go anywhere. So so this is kind of redundant, so we could actually just put something out to the console for now. Okay, let's not forget our semicolons. They're not necessary, but it's just good practice to have them. Some frameworks enforce them, so you know, it's just best to have them. So we have block, go anywhere. It looks like we have everything. Let's see what kind of errors we got. Let's go ahead and start going. Okay, the computer didn't go anywhere. And one of the problems that we have here, and you're gonna see, oh, it didn't. But one of the things about it is because we're drawing the board kind of early, so we probably got to draw the board down here after we do the AI. And let's see, we do in, do block, go anywhere. Let's see if it does anything now. Ooh, now it's kind of like we got errors. So let's see. Okay, so let's something in memory. Let's change something. Okay. Temp symbol. Okay, of course. And what line is that on? We just look for it. I'm not looking for it there. Temp symbol. I misspelled it. That's what I hate about these online editors. Well, it's not that I hate it, but I don't like it because I have a typo and I all I want to do is something very simple like control find, and I can't do that. So I got an error. I got a typo here where I got temp symbol, our symbol. So oh, here I got it all over here. Symbol here. Temp symbol located there, and I got it here too. Okay, temp symbol, so I got it there. See if I got it anywhere else. Temp symbol is fine there. Okay, let's clear it. Let's try it again. Oh, see, there's our logic. So now it's my move. I'm the X's, and I go here, and he decided to block me. And then let's see. Where do I want to go? Ooh, let's pull a good one on this one. Let's see if it can. It's smart enough to block me. Okay. See, it knew to block me there, but now I win here, and it still went because it doesn't know when the game is over. It doesn't know that I won. That's, I think, a good challenge where you can pick up this. This has gone long enough. So one of the things that you would have to do, figure out how would you take this to the next level and check that it won, and maybe draw a line straight up and down on this game. So I'm gonna go ahead and save this so I won't lose it. Let me close that. Let me go back to backup. Here we go. And we know what that's like. Let's just back up the logic. So we have the board game, and let's take our HTML here. Oh, did I just take it? Control Z and okay. Let's take all this. Control C, and it's our HTML. And so there you have it. So what would you do in terms of getting this game to actually be correct and stop when it's playing? So right now, what we have, you can play the game and the computer made its move. So we can make our move and the computer blocks us. And let's just make another random move, see if the computer is smart enough to win. Now you notice the computer can win right there, so that should be its move. So if we go, say for example here, it's going to try to win. See, and it does. It made its move to win. So there you have it. I'm going to share this code and see if I can. I'm not logged in, so I don't know what it's gonna do, but I have it packed up. So let me go ahead and log in or register. So I should already have an account. Okay, so I have it, and then I should be able to share it. Share, and let's see, link. I'll share on my Twitter feed, so you can go to my Twitter feed and get it from there, or I'll put it on the YouTube video too. So let's go to Twitter. Let's see. I don't want to put it just there. Let me put it up here. I just want to see what it is, if it actually takes me to it. Oh, and it does. So I'm going to put that on the video. Let me copy it over to the backup piece here. Okay. That's kind of interesting. Okay, so there you have it. Thanks for watching, and just if you have any questions, just go ahead and leave your questions down in the comments below. If you like this video, give it a thumbs up. Make sure to subscribe, so you can keep getting more videos like this. This was just something that I woke up this morning and I said, you know what, I don't have anything better to do than maybe try to figure out a little bit with this grid. In reality, I didn't learn much about the grid, but it seemed like something simple enough to do like a board game with. So anyway, thanks for watching, and until next time.